Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. So this is set 2 of 10 good problems on the chapter of cubes and cube roots. If you have not watched the video on set 1 problem solving of 10 good problems on the chapter of cubes and cube roots, then I highly request and suggest that you watch that video also. So this video is part of the playlist Maths 8 HOT. HOT stands for High Order Thinking, where I solve uh, problems of high order thinking from every chapter, which are completed in the as and when they are completed in the playlist CBSC Maths 8 RS Agarwal. So if you are new to my channel or not yet subscribed, and if you are watching my videos and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and also please do not forget to press the bell icon so that you will be notified by my future videos. So let's get started in solving the 10 good problems set 2 on the chapter of cubes and cube roots. Okay, so I have the 10 good problems set 2 on the left hand side, and on the right hand side I will solve the problems. So all the questions, there are 10 questions, all of which are MCQ. There are 4 choices and one choice will be correct. You have to select the correct choice. Ideally you should solve these 10 problems in 30 to 35 minutes if possible, and try your best to solve the problems with multiple attempts. And if you are stuck at any problem, then you are welcome to refer this solution video uh, uh, for the for your for the clarification of your problem, or uh, of your problem in solving a particular problem. Okay, so I will, after solving a problem, I will pause for a few seconds so that you can pause the video and take a screenshot of the solution. Okay, let's get start. Let's start solving the problems. Problem 1 says if 36 an equation is given, 36 a to the power 4 is equal to a to the power 6, then find the value of a cube. We have to find the value of a cube. Now the one way is that we are given 36 a to the power 4 is equal to 36. Now if I this implies that 36 is equal to a to the power 6 divided by a to the power 4, which is equal to a square. Now this definitely implies a is equal to square root of 36, which is 6. So we can easily find the value of a, which is 6. Now this implies a cube is equal to 6 cube. Now it is very essential that you must be remembering or knowing the cube of all the digits, as well as some 2-digit numbers like 10, 11, 12, 13, 14, 15. If you can remember them, it will help you in solving some harder problems. Now 6 cube is 216, but you can see in the choices absolute value is not given. It is, all the choices are given in terms of a, in terms of powers of a. So this method will not really help you. This method will not really help you. So what we can do, we have to find a cube. Okay, now we have to find, then the value of a cube is, okay, now let's see what is given. A to the power 6 is given to be 36 a to the power 4. Okay, now this implies, what is a to the power 6? A to the power 6, we can write it as 6, the power 6 we can write it as 2 multiplied by 3. This is equal to 36 a to the power 4. Now this implies, remember, we have to find a cube. We have to find then the value of a cube. Then the value of a cube. Okay. Hmm. Okay. So now what we can say is, so we have a to the power 2 into 3 is equal to 36 a to the power 4. Now a to the power 2 into 3 we can write as a to the power 3 whole square. Square of a to the power 3 we can write is as 36 a to the power 4, because we know that from the laws of exponents x to the power m and this whole raised to the power n is equal to x to the power m into n, and this can also be written, the powers can be interchanged, that is, this is also x to the power n and whole to the power m. Okay, so we get that a to the a cube square of a cube is equal to 36 a to the power 4. Now what will be a cube? Square of a cube is equal to 36 a to the power 4. So hence we can clearly say a cube will be square root of 36 a to the power 4. If we have something like x squared is equal to y, obviously we must know or understand that x is equal to square root of y. Now what is this? We have, this is 36 multiplied by a square, square of a square. Now what is 36? 36 is 6 square multiplied by we have a square and whole square. So this is equal to 6. We can say this is equal to 6 multiplied by a square whole square. Now this is definitely equal to 6 into a square, that is 6a square. Now the concept behind this is that if we must know that square root of x square, where x is some non-zero rational number, is always equal to x. So the answer is 6a square, and hence the correct choice is D. D is the correct choice. I hope the question papers, the questions are properly visible, and there the fonts are large enough so that you can see it properly. Okay. Is my video lagging? Okay. Anyway, let's do problem number 2. Problem number 2. It is a simplification problem. We have cube root of 288 multiplied by cube root of 432 cube root of 648. Now, as I said while solving the previous problem, that it is very essential you must know the square and the cubes of all the digits, as well as some at least square of some 2-digit numbers like 10, 11, 12, 13, 14 like this. But the single digit number, the digits, their squares and cubes you must already be knowing. Now from this we can clearly see that none of the numbers inside the root, inside the cube root are perfect cubes. 288 is not a perfect cube, 432 is not a perfect cube, and 648 is not a perfect cube. So we don't know their cube roots. So the concept we have to apply is that we know that cube root of the cube root of two numbers x and y, they can be positive or negative, but obviously they are not zero. Cube root of x and y is equal to cube root of x multiplied by cube root of y. Okay, so what we will do is we will put all the numbers inside a single cube root, because so this is applicable for two numbers x and y, but this can be extended for any numbers. Like if there was x, y, z, cube root of x, y, z is equal to cube root of x multiplied by cube root of y multiplied by cube root of z. So we can say that the given expression is equal to cube root of 288 multiplied by 432 multiplied by 648. Now we have to prime factorize all the numbers and form the powers of the prime factors. Then we can clearly find the cube root. Now prime factorization is one thing of numbers, natural numbers is one thing which will be heavily used in solving problems. So you must be very quick and fast in finding the prime factorization of numbers, at which I am extremely bad. Okay, so 2, 1, 44. You need not find all the prime factors. We have to form inside the cube root. We have to form powers of 3. Then we can find the cube root, because we know that cube root of anything with a power 3 or multiple of 3. Let's say x is a non-zero number. X to the power 3n, where n is some natural number. This is equal to x to the power n. X to the power n. Okay. So 288 we can factorize it as 2, and we know so this is a cube root. We have to form powers of prime factors, and the powers should be multiple of 3. Now 144 we know is 12 square. 144 we know is okay. For the time being, let's write it as 2 into 12 square. Okay, now 432. What is 432? Let's divide by 2. So 216. Okay, I see. So this is 216. I know is cube of 6. Cube of 6. Okay. So this is 2 into 6 cube multiplied by what is 648. 648. Let's divide by 2. 3, 2, 4. 324. No. Let's see, divide again by 2. 162. 162, and then again 281. Okay. So this is 2 cube. 2 cube. 648 is 2 cube multiplied by 81. Okay. Now we have to form powers of 3. Okay. Now 81 is 9 square. 81 is 9 square. We need another 9. Where can we get another 9? 3. Okay, I see. So this is equal to cube root of. Sorry for my really clumsy solution. I'm really sorry for that. Now, okay. So so we have 2 multiplied by, now 12 is 4 into 3. 4 into 3 whole square, and we have 2, and we have 6 cube, and we have 2 cube, and we have 9 square. 81 is 9 square. This is equal to cube root of 2. 4 into 3 whole square is 4 square multiplied by 3 square, and we have 2, and we have 6 cube, and 2 cube, and 9 square. So this is equal to cube root of so we have 2. We can see consider the factors of 2. We have 2 square multiplied by 2 cube, and we have 4 square is 2 to the power 4, and 3 square can be written as 9, and there is 9 square, so I get 9 cube, and I have 6 cube. Okay. Okay, so this is equal to, let us now merge the powers of 2. So we have 2 square, 2 cube, and 2 to the power 4. So it becomes 2 to the power 9. That is 3 plus 2 plus 4. And we have 9 cube, and we have 6 cube. This is equal to cube root of 2 to the power 9 can be written as 2 to the power 3 whole cube into 9 cube into 6 cube, and this will be equal to 2 cube multiplied by 9 multiplied by 6, as we know that cube root of uh, x cube root of x cube, y cube and z cube is equal to x, y and z. Now this is equal to 8 multiplied by 9 multiplied by 6, and this is equal to 72 multiplied by 6. This is equal to 432. This is equal to 432. So the answer is choice A. Okay, let's do problem number 3. The product 824 into n is a perfect cube. What is the smallest possible value of n? Okay, so it is basically asking what is the least number that must be multiplied with 824 to make it a perfect cube. Make it a perfect cube. So we have to find the prime factorization of the number 824. Let's divide by 2, we get 4, 1, 2, and then again divide by 2, we get 2, 0, 6, and we get 1, 0, 3, and the product of 824 into n is a perfect cube. Okay, so we have to find the least number that is the n, which is the smallest value of n, such that 824 multiplied by n will become a perfect cube. 3, 4. Is it divisible by 7? No. 7, 9, 103. I think I did something wrong. Let me check again. 2, 4, 1, 2, 2, 6, 103 is a perfect cube. The product of is a perfect cube. What is the smallest possible value of n? 103. Because 103 is a prime number. 3, 9. $824 or 2412 or 2206 103 8 24 8. Perfect cube. What is the smallest possible value of n? Four. Seven, 63. 103. So we can see 824, the prime factorization of 824 is 2 cube multiplied by 103. Now the least number that need to be multiplied with 824 to make it a perfect cube has to be 103 square, but the choices are very less. What is the smallest possible value of n? 824. 3, 9, no, 7. Is a perfect cube. What is the smallest possible value of n? I'm not sure how the choices are so small numbers 1, 2, 4, 3. The prime factorization is coming to be 2 cube multiplied by 103, and ideally 824 should be multiplied by 103 square. 103 square to make it a perfect cube, because uh, 3, this is to 3. Oh, okay, I don't know, I'm stuck here. I will put a question mark and move on to the next question. Uh, Question number 4. Uh, so an equation is given and there is an unknown x and it is asking to find the value of x. Okay. So what is given? Square root of 8 multiplied by square root of 8, this whole raised to the power half, divided by 9 raised to the power half, is equal to x plus square root of 8 minus 340. Okay. So this implies, what is the left hand side? We have to simplify the left hand side. Now square root of 8 into square root of 8 is equal to 8, and we have 8 raised to the power half divided by uh, 9. So we have 9 can be written as 3 square, and we have power half is equal to x plus root 8 minus 340. Now this implies um, this implies uh, now power half means any number raised to the power half means square root. So we have square root of 8 divided by square root of 3 square is equal to x plus root 8 minus 340. So this implies root 8 divided by 3 square, square root of 3 square is 3, is equal to x plus root 8 minus 340. So this implies square root of 8 divided by 3 means square root of 8 divided by 3 is equal to x plus root 8 minus 340. So this implies the value of x is if I transfer all the constant terms from the right hand side to the left hand side, we get 340 plus square root of 3 by square root of 8 by 3 minus square root of 8 equals x. This implies square root of 8. I think when the value of x is I think the problem is not correct. Correct. I might have done some mistake in copying the problem. From this, we will definitely not. From this equation, we will definitely not get a value of x as an integer, but all the choices are given as integer. The value of x is 19 minus 340. If I consider all the choices, for all the choices, the right hand side will become a negative number. The right hand side will become a negative number. So how, and but the left hand side is definitely a positive number. I might have done something wrong in copying the problem. Mm, is it square root or is it cube root of 8? Maybe in the problem it will be cube root of 8 instead of square root. If it is cube root of 8, then we have on the left hand side 2 multiplied, cube root of 8 is 2. So 2 multiplied by 2 is 4. 4 to the power half is 2. So we have 2 by 3. 2 by 3 is equal to, no, I don't know. The question looks incorrect to me. The equation is not really correct. This equation will definitely not give the value of x. Value of x will not match with any of the given choices. So I'm really sorry. Another question mark. I will move on to the next question. The cube of the number m is 16 times the number. The cube of the number m, there is a number m, its cube is m cube. It is said that the cube of the number m is 16 times the number. So it will be 16 times 16m. Then find m if it is given that m not equals to 0 and m not equals to minus 4. Okay. Now we have this. Now this implies since it is given that m not equals to 0, we can always divide both the LHS and RHS by m. Dividing by m both sides. Dividing by m both sides, we get m square is equal to, we get m cube by m equals to 16m by m, and this implies m square, m cube by m is equal to m square. Using the laws of exponents, we know that x to the power m divided by x to the power n is equal to x to the power m minus n. This implies m square is equal to m cancels out in the on the right hand side 16. So we have m square is equal to 16. This implies m is equal to square root of 16. Now this is equal to 4. This is equal to 4. So the correct answer is choice is D. Now if in general, if m square is equal to 16, then m can have the value plus 4 and minus 4, because minus 4 square is also 16 and plus 4 square is also 16. But remember that square root of 16 always represents the positive square root, that is 4. Okay, so let's do problem number 6. If p and q are perfect cubes, then the value of cube root of p by q is integer, rational, whole number, none of these. If p and q are perfect cubes, then if p and q, p is a perfect, it is given that p is a perfect cube, this will imply that P must be of the form m cube for some natural number m, for some natural number. If P is a perfect cube, there must exist some natural number m such that m cube is equal to P. Similarly, we will have Q is a perfect, given that Q is a perfect cube. So this implies Q must be equal to n cube for some natural number. Since Q is a perfect cube, there must exist some natural number n such that n cube, whose cube will be equal to Q. N. Now this implies cube root of P by Q, is equal to cube root of P, we know, is equal to m cube, and Q is of the form n cube. So this is equal to cube root of m by n cube, and this is equal to m by n, and this is a obviously we cannot say this is an integer. You cannot say for sure that m by n is an integer where m and n is a natural numbers, but definitely it is a rational number. It is a rational number. And also we know that n will not be equals to 0 because m and n are natural numbers. So you cannot say for sure that m by n will be a whole number or integer. So hence, but we can surely say that m by n will be a rational number. So the correct choice is B. B is the correct choice. Let's solve problem number 7. It is a simplification problem. Okay. So we have to find the cube root of minus 2197 divided by 1331 plus cube root of 27 by minus 512, and we have plus square root of 4 is a mixed fraction, 4 and 29 by 49. Now in all these numbers, I know 27 is a perfect cube, 512 is a perfect cube, 1331 is a perfect cube, but I am not sure about 2197. It must also be a perfect cube. So let's quickly see the prime factorization of 2197. Now it is not divisible by 3, 16, 17, 19. It is not divisible by 9. Is it divisible by 7? 11. 11 minus 8. 11 minus 8 is 3. No, it is not divisible by 11. It is divisible by 7. Is it divisible by 7? 2, 1, 9 minus 14 is equal to 2, 0, 5. 205, 14, 6. No, it is also not divisible by 7. How do I prime factorize this? 7. So 2197 is ending with its digit 7. So what can possibly its cube root end with what digit? 7. Now its cube root may end with the digit 3, because cube root of cube of 3 is 27. So the number 2197, its cube root, that may end with the digit 3, or it can also end with the digit 7, because 7 into 7 is 49, and 49 into 7 is ends with the digit 3. Now, okay, so it is for sure that the cube root of 2197 will end with the digit 3 or 7. So what can the cube root be? Can it be 13? 13 into 13. Let's see what is 13 into 13 is 69. 13 into 13 is 169, and what is 169 into 13? 27, 25, and we have 9, 6, 1, and we have 7, 9, 11, 2. Okay, so it is the cube root of 2197 is 13, because we can see that 13 cube is equal to 2197. Okay, so this we can write as cube root of, so we can see that 2197 is a perfect cube, perfect cube. In fact, minus 2197 is a perfect cube, as its cube root will be minus 13. Now, what about the mixed fraction, that is 4 and 29 by 49? 4, 29 by 49, if I convert it to an improper fraction, this becomes 36, 36, okay, 16, 19, 14 square, 36, plus 29 by 49, this is equal to 5, 225 by 49. Okay, so 225 is a perfect square and 49 is also a perfect square. Okay, so now we can okay, so cube root of minus 2197 divided by 1331 can be written as cube root of minus 2197 divided by cube root of 1331, plus this will be cube root of 27 divided by cube root of minus 5112, and plus we have square root of 225 by 49. So this becomes equal to cube root of minus 2. Okay, so cube root of minus 2197 is cube of minus 13, and 1331 is 11 cube, plus we have 27 is 3 cube, and 512 is minus 512 is minus 6 cube, plus we have square root of 225 means 15 square divided by 49 is 7 square. So now this is equal to, we can say minus 13 by 11 plus 3 by minus 6 plus 15 by 7. So this is equal to minus 13 by 11 plus minus 3 by 6 plus 15 by 7. So this is equal to, the LCM will be 6 into 7 into 11, which is equal to 42 into 11, which is equal to 42 and 42, 462, 462. Eleven. 512. What is the cube root of 512? Oh no, 512 cube root is not 6. It is 8. 8. Sorry. Cube root of 216 is 6. So this will be. This is not 512 minus 512 can be written as minus 8 cube. So this is minus 8, and we have over here 8, and we have over here 8. So the LCM will be LCM of 11, 8 and 7 is uh, 48 into 11, 48 into 11. So that what is 48 into 11? 528. 528. So the LCM is 528, and we will have over here 56, 8 into 7, 56 multiplied by minus 13, plus we will have minus 3 multiplied by 11 into 7, 77, and plus we have 15 multiplied by 88. So this is equal to what is 56 multiplied by 13? 16, 56, 8, 12, 728. So we have minus 728 minus 77 into 3 is 21, and 23 to 31, and we have plus 88 into 15, which is 40, 44 multiplied by 88, 0, 12, 13, 1320 by 528. So this is equal to minus 959 plus 1320 divided by 528. This is equal to 1, 10 and 6 and 6 and 10 and 3. Why? This is 361 by 528. This is the final value of the given expression. So the correct choice, wait, minus 959, and we have over here 1320. 88 into 15 is 40, 40, 44, 88, 12, 5, 13. How much is 1320 minus 959? 1, 6, 361. The answer is coming out to be 361 by 528, but it is not given in the choice. There is 261 by 528 and minus 261 by 528. What is wrong? Minus 728. 56 into minus 13. How much is 56 into 13? 18, 16, 56, 8, 12, 7, 728 is fine. Minus 728. I hope 11 cube is 130, 1331. I will check it once again. 11 square is 121. 121 into 11 is 1 21, 1, 21, which is 1, 3, 3, 1. It's fine. So we are having 13 minus 13 by 11, okay, and we are having 3 by minus 8 and 15 by, oh sorry, oh okay, so that was square root. The last term was square root of 225 by 49, which is 225 is 15 square and 49 is 7 square, that is 15 by 7. Okay, so minus 13 by 11 plus minus 3 by 8 plus 15 by 7. The LCM is LCM is 8 into 11 into 7, that is LCM is 56, 56, 6, 11. Oh, sorry. How much is 11 into 8 into 7? That is not 528. That is 56 multiplied by 11, which is 616. So this is 616. This is 616. This is 616. So we have 6. We have 616, 616. Okay. So the answer is choice A. Let's do problem number 8. It says two perfect cubes ends with m and n number of zeros. Okay, so there are two perfect cubes which ends with m and n number of zeros. Then n square plus n square is a multiple of. Okay. Now any cube, the concept is any cube, any perfect cube will end with 3n zeros for some natural number n, for some natural number, for some where n is a natural number. If you take any number zeros, so if any perfect cube ends with zeros, it will always end with as many number of zeros which is a multiple of 3. So the number of zeros in a perfect cube will always be of the form 3n, that where n is a natural number. Okay. So this implies that it is given that the two perfect cubes ends with m and n number of zeros. So this implies m, the number of zeros in the first perfect cube is m. So we must have m is equal to, in the form of 3, let's say p, where for some natural number p, m must be a multiple of 3. Hence we are saying that m is of the form 3 into p, where p is some natural number. Also n has to be equals to multiple of 3, let's say this be 3q, for some where q is also some natural number, for some natural number q. Okay, so this implies m square plus n square will be equal to 3p square plus 3q square. So this is equal to 9p square plus 9q square. This is equal to, if you take 9 common, we have 9 into p square plus q square, and definitely this number 9 into p square plus q square, we do not know what will be p and q, but we can definitely say that this is divisible by 9. Divisible by 9. So the correct choice is D. D is the correct choice. Okay, let's solve problem number 9. It is given that y is equal to cube root of, we have 729 multiplied by 9 multiplied by 81. Then the value of square root of y. Okay, so we have to find square root of y. Okay, so y is given as cube root of 729. Now this is 729 can be factorized as, now 729 is cube of 9. Seven 29 is cube of 9, and we have 9, and we 81 is 9 square. So this is equal to cube root of 9 cube multiplied by 9 cube. This is equal to cube root of 9 cube multiplied by 9 cube. We can, using the laws of exponents, that x to the power m multiplied by x to the power x to the power and y to the power m is equal to xy to the power m. So we have 9 multiplied by 9 whole cube. This is equal to 9 multiplied by 9. Since we know that cube root of x cube is equal to x. So y is equal to 9 into 9. This is equal to 9 square. So this implies square root of y is equal to square root of 9 square, which is equal to 9. So the answer, correct choice is B. B is the correct choice. Question number 10. Okay, so it is given, an equation is given, 27 cube minus 13 cube divided by 2 is equal to k into 898 plus 27 multiplied by 13. We have to find k. We have to find k. Now on the left hand side, we are having 27 cube minus 13 cube. It is of the form. So you must be familiar with the algebraic identities, that a cube minus b cube is equal to a minus b multiplied by a square plus ab plus b square. Now, so in the left hand side we can see some form of a cube minus b cube, that is 27 cube minus 13 cube, and on the right hand side you can see the term a into b, that is 27 multiplied by 13. Now what is 898? What is 898? Ideally we would like, we can expect, ideally we would like to have 898 to be equal to 27 square plus 13 square, because we know that a cube minus b cube is equal to a minus b multiplied by a square plus ab plus b square. The factor of k on the right hand side, we can see there is, the second term is 27 multiplied by 3, and there is some term 898 with addition. So hopefully 898 probably can be the value of a square plus b square, that is 27 square plus 13 square. So let's see, 13 square we know is 169, but I don't know what is 27 square. So let's see what is 27 square. 49, 18, and we have 14, 5, 9, 12, 729. 729 is 27 square. Okay, and 13 square is 169. So 27 square plus 13 square is equal to 729 plus 169. This is equal to 8, 9 and 8. See, this is equal to 898. So this is equal to, we can say on the right hand side, 898 can be written as 27 square plus 13 square, and we have plus 27 multiplied by 13. Okay, now the left hand side, a cube minus b cube, using the formula identity, a cube minus b cube is equal to a minus b into a square plus ab plus b square. We can write a cube minus b cube as 27 minus 13 multiplied by 27 square plus 13 square plus 27 into 13 by 2, we get is equal to k into 27 square plus 13 square plus 27 multiplied by 13. So the factor 27 square plus 13 square plus 27 into 13 can be cancelled out from both the left hand side and the right hand side. So we get 27 minus 13 by 2 is equal to k. So this implies 27 minus 13 is 14. 14 by 2 is equal to k. This implies k is equal to 7. This implies 5k is equal to 7 multiplied by 5 equal to 35. K is equal to 35. So the correct choice is C. C is the correct choice. Now let's go back to the questions, two questions which I marked as question mark, which was those question. Question number 4. Question number 4 is this one. Square root of 8 multiplied by square root of 8. Now even if the square root of 8 is, if the square root of 8 would have been cube root of 8, then on the left hand side we would get cube root of 8 is 2. So 2 multiplied by 2, which is 4. 4 to the raised to the power half, which means square root of 4, which is 2. And square root of 9 is 3. So 2 divided by 3. The left hand side will become 2 divided by 3 if instead of square root of 8 it is cube root of 8. But still the value of x cannot be integer, but all the choices given are integer. I think there is some mistake in the problem, in the question. I will have to check. And then what was, then the question number 3. The product 824 multiplied by n is a perfect cube. What is the smallest possible value of n? So basically we have to find the least number that must be multiplied to 824 to make it a perfect cube. So we have to find the prime factorization of 824, which is 2. If you divide by 2, we get 4, 1, 2, and then again if we divide by 2, we get 206. And then if you again divide by 2, we get 103. 103. 7. What is the smallest value of n? No. I will have to check also, check this question whether I have copied incorrectly or not. With maybe the choices are incorrect, or maybe the 824, that number is incorrect. I don't know. And okay, so these two questions are I couldn't solve. I doubt that the questions are incorrectly copied. I'm sorry for that if that is the case. So this brings to an end of solving not really 8 questions, 10 questions, but 8 good questions which are relatively harder compared to the problems we have done from the textbook of author R.S. Agarwal. So these problems will give you a good evaluation of your understanding on the concepts of cube roots, cubes and cube roots. So if this video was beneficial, then please like it, share it with your friends, and once again, please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. So please stay tuned for more sets of 10 good problems on the chapter of cubes and cube roots. And also please look out for my theoretical videos in the playlist CBSE Maths 8 R.S. Agarwal if you want to have a good understanding of the chapter concepts. So thanks for watching, and until the next video, take care and bye.